In this video, we are going to talk about two important principles, sum rule and product rule. They are very widely used in probability. Let's try to understand what is sum rule and product rule in probability. Sum rule, right? So, when you want to find out probability, of two different events, right? So, when you are having two different events and you want to find out the probability that either of two event occurs, any one event occurs, either of two or more event occurs, then we apply sum rule, right. So, any one of the event occurs, then we talk about sum rule. So, for any two events A and B, P of A union B, right, is equal to P of A plus P of B minus P of A intersection B, right. This is for finding out the probability when two different event occurs, any one of the two event occurs, right. And there could be another case where if you have mutually exclusive events. What is mutually exclusive events? That both the events cannot happen at same time. When they cannot happen at same time, in that case, when they cannot happen at same time, then there is no scope for intersection of the events. There is no common element in both the events. Therefore, this becomes 0. So, P of A union B equal to P of A plus P of B. This is in sum rule. Let us understand that. So, this is for the mutually exclusive events. So, when there are two events A and B and they are mutually exclusive, means there is no common part in both of them. In that case, the sum rule formula is P of A union B equal to P of A plus P of B. We do not have the intersection part here, okay. And if they are not mutually exclusive, general rule, we do not specify about mutually exclusive, explicitly we do not talk about it, so generalized rule of sum, right. So, when the events not necessarily mutually exclusive, in that case the probability of union of these events is nothing but P of A union B equal to probability of A happening plus probability of B happening minus the probability of A intersection B, P of A intersection B. So, there is some common part here, they are not mutually exclusive, there are some common outcomes in both the events. In that case, we apply this as the sum rule. So, let us see an example, let us study one simple example to understand how and where sum rule is used. So, Mary has 2 green skirts, 3 red and 4 blue skirts. To choose for her outfit today, from these 3 different number of colored skirts she wants to choose. So, she chooses a skirt randomly with each skirt equally likely to be chosen. So, what is the probability that Mary chooses a green or blue skirt? Right? I want to choose from that. So, let us see, let define two events. Let event G be Mary choosing a green skirt and B be Mary choosing a blue skirt. Then Mary cannot choose both green skirt and a blue skirt. We cannot choose both green or blue. So, the rule of sum applies here, right. So, what is the formula here? See, there is no common part. Why there is no common part? Why there is no G intersection B? Why this is 0? Because there is no common, they are not happening, there is no common data here. Event A is separate, event B. At a time both cannot happen. If I choose one randomly, right, it cannot be green and blue both. It could be either green or blue. Therefore, we have for mutually exclusive events, so P of G plus P of B. Now, what is P of G? How do you find out P of G value? Total how many skirts are there? You see 2 plus 3 plus 4, we have 9. From this 9, what is the probability of choosing 2 green? It is 2 by 9. And what is the probability of choosing blue skirt from that? Since we have 4, it is P of B is nothing but 4 by 9. So, if I add it, it becomes 2 by 3. So, the probability that Mary chooses a green or blue, any one green or blue is 2 by 3. Okay. So, this is one simple example to make you understand how sum rule works. Let us see another example of sum rule. In a bag there are 34 marbles. Okay. In a bag there are 34 marbles. Out of 34 there are 14 blue. So, total number of blue marbles are 14, right. and 4 of those marbles are both blue and stripped. It means P of B is given as 14 and P of B intersection stripped are 4. So, intersection is there. There are some common marbles which are both blue and stripped. 16 marbles are stripped. So, P of S is nothing but 16 is given to us, right. Now, 16 marbles are stripped. Of those marbles, same 4 marbles are both blue and stripped. Again in 16, there are 4 which are common both. It means B intersection S is 4. Now, what is the probability that you draw a marble from the bag that is either blue or stripped? So, they are asking us to find out P of blue union stripped. So, you have the data with you. So, P of B plus P of S minus P of B intersection S. So, what is the value of P of B here? P of B we know from the question it is 14 plus P of S is 16 minus 4. So, what is the value here? If you subtract, you get here 26, right. So, if you see here, yeah. So, in this case that is what normally we do in set, right. So, 14 by 34 P of B plus P of stripped one is 16 by 34 minus 4 by 34, it is 26 by 34, right. So, that is 13 by 17. So, the probability of drawing a blue or a stripped marble is 13 by 17, right. I hope you understood how we got this P of B. P of B is given in the question that they are 14 out of total 34 and P of stripped are given as 16 out of 34. And we are also given that there are 4 common marbles which are both blue and stripped. So, P of B intersection T is given to us as 4 by 34. Applying them in the sum rule principle, we get the answer as 13 by 17. Okay. So, this is the application of sum rule. Let us go and understand about the product rule. Where do we use this product rule? Okay. So, product rule helps calculate the probability of 2 or more events happening together. When 2 events are happening together, that is intersection of events, there we use probability. Okay. We use this product rule of the probability, right. So, if you see here P of A intersection B, because 2 events are happening. In the previous example, if you remember, when I talked about P of B intersection T, what does it means? It means the marbles which are both blue and stripped. So, both the things are happening on the marble, it is blue and also it is stripped. So, wherever we have such kind of probability, we apply product rule, right. It helps in calculating the probability of 2 or more events happening together, right. So, the rule of product is used to find the probability of intersection of events. When 2 events are happening together, we use product rule. So, what is the formula of product rule here? P of A intersection B is equal to P of A into P of B. Let us try to understand this with an example. Okay. See here, a 6-sided fair die is rolled twice. I am rolling a die with 6-sided twice. What is the probability that both rolls result in 6? See, a 6 die is rolled 2 times. I am rolling a single die. So, if I roll a die first time, okay. Sorry, if I roll a die first time, getting probability of 6 first time is 1 by 6. Again second time I am rolling it. What is the probability of getting 6? Second time it is also 1 by 6, because we know that when I roll a die, probability of getting a 6 is 1 by 6 chances. The probability is 1 by 6. So, 2 times I am getting this. The question is, what is the probability that both the rolls result in 6? So, we apply, because 2 events are happening, intersection of 2 events. The question is to find out what is the probability that both the rolls result in 6. So, rolling one time is 1 by 6, rolling second time is also 1 by 6. So, if you combined probability is 1 by 6 into 1 by 6, that is 1 by 36. So, probability that both the rolls are, that is what, it is simple as that. You roll a die 2 times, right. What is the chance of getting 6 and 6 in both? So, if you just see, normally even without this product rule, maybe you can guess the outcome of this. How? If you see here, getting 1 is 1 by 6 time and getting 1 second time is 1 by 6 time. So, totally it is 1 by 36, getting 1. Same way getting 2 is also 1 by 36. 2 after 2, getting one time 2, another time 2. That's why we have combination of 1 is possible, 1 comma 2 is possible, 1 comma 3 is possible, 1 comma 4, 1 comma 5 is possible, 1 comma 6 is possible. So one die can give a number 1, the other one can give 1 to 6, any number. Second time when I do, there is a chance it could get 1 or 2. Like this, if you count, you have total 36 possibilities. So among those 36 possibilities, what is the probability of getting 2 6s? It is 1 by 36. Okay. So this is a simple example of product rule, right?